Alright, welcome. We're going to do a review of expressions today based on our discussion in class. Some of us just need a few refreshers on multiplying expressions. So if we have 3x to the 4th times 7x to the 7th, when we have the same base, and so that would be they're both x's, and when we are multiplying, we are going to add the exponents, or we add the powers. And so we would have 21, because we do the 3 and the 7, multiply those, and then we have x to the 4th times x to the 7th, and so we are going to add those exponents, so we get x to the 11th. If you ever are unsure, it's so nice. You don't have to memorize this. Just think about this. If you had x squared times x cubed, that's really x times x times x times x times x. So how many x's is this? 1, 2, 3, 4, 5. X to the 5th. And so that would remind you, oh yeah, that's right. When I multiply them, I add them. So I never want you to have to memorize. You can always create a simple situation to remind yourself how it works. The same will go for an example like this. You're not really sure. Well, when you are powerizing, which is x to the 7th to the 2nd power, well, let's see, when we were multiplying, we added the exponents. When we powerize, we are going to multiply the exponents, or the powers. So this would be x to the 14th. And again, you don't have to memorize that. Let's take a simple situation. Let's take x cubed raised to the 2nd power. So that's x cubed times x cubed. So you know that when you multiply, you add the exponents, so you'd get x to the 6th. So, the 3 and the 2, so I should have gotten a 6. So that's right, I multiply the exponents. And here, even if you forgot how to multiply the exponents, or how to multiply and then add the exponents, you would break this down into x times x times x times x times x times x. This is your x cubed. This is another x cubed. So here are two rules for you to remember. When powerizing, you multiply. When multiplying, you add. Of course, that applies to when you have the same base. All right, so let's look at some different situations. Let's say we had 3x to the 6th times 4x squared y to the 5th. So first we're going to take our 3 times our 4. We'll get 12. We have the same base here, so we're going to add the 6 and the 2. So we'll get x to the 8th, and then we just add on the y to the 5th. Now, what would happen if this problem was plus a 3x to the 8th? Well, now we're getting into talking about like terms. I see that both of these have x to the 8th, but I have a y to the 5th here, and this term does not have a y to the 5th. So this is my final answer. I cannot simplify this anymore. Same thing if you had x plus x squared plus x cubed. You cannot simplify that. It cannot be simplified. Because these are not like terms. They do not have the same base raised to the same power. Y squared plus x squared plus z squared also cannot be simplified. So let's do a few practice problems. To help us orient ourselves and apply these properties. Also, please keep in mind that we have these rules. When multiplying, add exponents. When powerizing, multiply the exponents. And then finally, when you're adding, as one of my students said today, you keep the exponents the same. So do not touch the exponents. In other words, if you have 3x to the 6th plus a negative 5x to the 6th, you should end up with something x to the 6th. You keep this exponent. It does not change. So I would have a negative 2x to the 6th. So if you wanted to memorize 3 rules today, it would be these 3 highlighted in an orange. But I don't want you to memorize, because you should be able to sort those out all by yourself. If you aren't sure whether you keep the exponents, ask yourself, if you have x plus 2x, wouldn't that give you 3x? But maybe, are you thinking, could that be 3x squared? Well, if you are, you don't have to memorize this. You can just test this. Let's say x equals 4. And let's test this and make sure 4 plus 2 times 4, okay, that's 4 plus 8. That gives me 12. So would 3x, if x is equal to 4, would that give me 12? Yeah, okay, so that works. So I know that my 3x is correct. And so notice I did not change the exponents. I just added the coefficients, and I kept my exponents the same because I was adding. So that is some overview. And now let's start putting this together in different circumstances. Actually, I want to do this. Times. Okay. For starters, I need to be aware of my order of ops. So notice I was adding my exponents here because I was multiplying. Each of them has an exponent of 1. As a result, I got an exponent of 2. Now, can I combine like terms? I see this and this are similar. So I'm going to change this to addition of the inverse. So now I can rearrange the order. So 3x plus a negative 4x plus x squared. So I'll get negative x plus x squared, or you could also write that as x squared plus a negative x, or x squared minus x. All right, so 3x squared y to the 7th times 4x cubed plus negative 3y. So I'm going to distribute. 3 times 4 is 12, x to the 5th, y to the 7th, plus a negative 9x squared y to the 8th. Don't forget to do this second distribution. And don't forget that when you have the same base, you are adding the exponents, and this 3y is really like 3y to the first power. Now let's try this problem. So I'm really going to have to differentiate between whether I'm adding or multiplying or powerizing. So let's focus on the 7x to the 5th squared. If you want to write that out, that might help you out. So that's going to be 49x to the 10th, because when we powerize, we are going to multiply these. So I have 3x to the 10th plus 49x to the 10th. Those are like terms. I will add them. I will keep the exponent the same because I'm adding, and I will get 52x to the 10th. Now again, we're going to have to differentiate between multiplying, powerizing, and adding. So let's multiply first. 32x to the 6th plus, I'm going to end up getting a positive. I really don't need my parentheses anymore. I'll get 36x to the 6th. And now I can add them Well, can I? Are they like terms? Are they the same power to the same exponent? Yes. So I will get 68x to the 6th. And that is now simplified. So that was a very brief overview of adding, multiplying, and powerizing algebraic expressions. In other words, simplifying. And that was very brief because it should be some review. If you need some extra practice problems, you can feel free to reach out.